Now let's talk about how to find the equation of a line. We have the general equation for finding the equation of line, that is y equals to mx plus c, where m is the gradient, c is the y-intercept. C is the y-intercept, which you could see over here. This is the point where a line is when a line is intersecting y-axis. So it is right now passing through this one. In most, you can use this equation, and there is another equation which you could use, which is y minus y1 is equals to m into x minus x1. So I am going to definitely tell you, it's up to you whatever equation you want to use. So you should know probably both the method of using the equation. So first we will talk about this y equals to mx plus c. We have the coordinates a1, 2, b3, 4. First we will use this for finding the gradient, and the gradient will be 4 minus 2 upon 3 minus 1, which is 1. Now we have to substitute the value of the gradient in this equation, and any one coordinate, either you take a or the b, it's up to you. No hard and fast rule here, it's up to you. You can use any of the coordinate in your equation. So I am considering this coordinate a 1, 2. So y is equals to 2, m is 1, this x is 1 also. You could see here, this is your x and y right now, and we have to find the value of c first. So 2 minus 1 is equals to c, and c is equals to 1. Alright, so once we have found the value of c, just substitute it back into the equation, y equals to mx plus c. Now we know the value of c and the value of m, which is important. Just substitute it back into the equation and your equation will be ready. So m is 1, x will remain the same, and this c is also 1. So we have this equation y equals to x plus 1. So this is the equation of this line. Now let's see how do we use this equation for finding the equation of line. So we have this equation y minus y1 is equals to m into x minus x1. Normally or personally I like this equation pretty much, but it varies from person to person. So it's up to you whatever equation you want to use. So let's draw the diagram again. This is 1, 2 and 3, 4. You have to find the equation of this line AB. So how do you use this y minus y1 equals to m into x minus x1 for finding the equation of this line AB? What I need here is this gradient and any one point. Either I could use A or I could use B. So I would like to use now B. It doesn't matter, you could use any of the point. So this will be my x1, y1. So I will just substitute this value in it. The gradient I know already, 4 minus 2 upon 3 minus 1, which is 2 upon 2 equals to 1. Just substitute this into the equation. Y1 is 4. From here y1 is 4 is equals to m is 1 also, then the x minus x1. So x will remain the same, this x1 is 3, so my y minus 4 is equals to x minus 3. shifting this minus 4 to the right side. So y equals to x minus 3 plus 4 and y is equals to x plus 1. So that's how we can use any of the equation. Either you want to use y equals to mx plus c, or either you want to use y minus y1 equals to m into x minus x1. It's up to you. Alright, so now in this one we'll have a look at the question where one line is parallel to the other line. As you could see in the question, find the equation of the line passing through the point A and parallel. What does that mean? When two lines are parallel to each other, we have already discussed this property. Whenever two lines are parallel to each other, so the gradient of first line would be the same or would be equal to the gradient of the second line. So over here, line is passing through point A 2, 1 and parallel to the line y equals to 2x plus 5. So it means that this line has the gradient m is equals to 2. If you could see here, this is m equals to 2, this is the gradient. The line that is passing through the point A will also be experiencing the same gradient because they both are parallel to each other. If m is equals to 2, then I am going to make an equation through it. A2, 1, these are the points, and m equals to 2. So whenever two lines are parallel to each other, you need to take out the gradient from the other line and then substitute it back to the equation. We have the equation y equals to mx plus c. Either you can use this equation. I would prefer to use this equation. Y minus y1 is equals to m into x minus x1. So just substitute all the values in it. So y minus 1 is equals to 2, x minus 2. Then this equation will become y equals to 2x minus 3 upon simplification. That's the key to this question. Now look at the another question in which we'll be having a straight line will be passing through A and perpendicular to the line. Now in this question we have to find the equation of a straight line passing through A and perpendicular to the line y equals to 3x plus 1. Most important thing is this perpendicular condition. Whenever we know that if one line is perpendicular to the other line, so it should be equals to somewhat like this. Even you can say m2 equals to minus 1 upon m1. So we can use the gradient of this equation for finding the gradient of the other line because they are perpendicular to each other. So we have m is equals to 3 from here. Now I will put it back into this one so that I could get the gradient for the perpendicular equation. So minus 1 upon 3. So this is the gradient I got for my next equation. Now I will definitely and we have also been given with the point that is 2 comma minus 3. So we have this Chernal equation y1 y minus y1 is equals to m into x minus x1. So y minus minus 3 substituting x1 and y1 from this part A, m is equals to minus 1 upon 3. This x and this x1 is 2.